Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper from the Hugging Face Trending List, published on December 5th, 2025, about 3 days ago. It introduces a deliberative think-while-edit loop, where a multimodal large language model critiques each edited image, refines the instruction, and repeats the edit, which in turn boosts instruction following for many existing image editors by a large margin. The paper is titled EditThinker, Unlocking Iterative Reasoning for Any Image Editor. And as we will see later, the implications for making image editors more reliable are quite significant. Figure 1 summarizes how EditThinker turns image editing into an iterative thinking loop and how much this helps in practice. The top panel shows several examples where the model critiques each edited image, rewrites the instruction, and gradually improves the result across turns. In the lower row of examples with the cat, the style, pose, and background align better with the original after each refinement. The bottom charts report benchmark scores, which rise steadily when EditThinker guides existing editors compared with their original single-turn behavior. Figure 2 shows how the think-while-edit loop actually runs through multiple rounds with the same photo and instruction. The top row illustrates the editor generating an initial edit from the source image and text, then receiving progressively refined prompts. The bottom row illustrates EditThinker, which inspects each edited image, writes out reasoning, and assigns semantic and quality scores. If the overall score stays below a threshold, the system launches another round. Once the score is high enough, it stops. Figure 3 explains how the authors generated the training data that teaches EditThinker to run this multi-turn loop reliably. The large diagram shows a pipeline that starts from an edit data pool, runs the think-while-edit process with an expert model, and records full trajectories. The central blocks then filter those trajectories using an edit scorer, so only high-scoring steps remain. On the right, the pie chart and bar chart summarize how tasks and quality scores are balanced across the final dataset. So while Figure 3 described how the data was built, Table 2 shows how different editors handle reasoning-heavy edits on the RISE benchmark. The table breaks scores into temporal, causal, spatial, and logical reasoning, plus an overall column. The upper block reports strong proprietary systems, while the middle block lists weaker open-source editors. The bottom think-while-edit rows reveal that pairing these same open-source editors with EditThinker dramatically lifts their overall reasoning scores. Alright, to wrap up, the big idea is that letting image editors think while they edit, with a multimodal large language model critiquing and refining instructions, consistently boosts instruction following without retraining the editors themselves. This points toward future creative tools that are more collaborative, self-correcting, and reliable. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.